Hello, today I've got a bit of a random video for you. Today we're going to be making the dragon curve in Java processing. I've recently fallen down the rabbit hole of binging the coding train videos where there's this wonderful man called Dan Schiffman who will undergo these programming challenges to make something in processing or in its JavaScript counterpart in some sort of time limit. So I've decided to download the software myself to see what I could do, and I found that he hadn't done the dragon curve yet, so I thought I could take a stab at it. Now, I'm not as crazy as him, so I won't be doing this in any sort of time limit. And I'm strictly a Java man, so this is going to be all done in Java. I'm hopeless with JavaScript. If you enjoy this type of video, I actually highly recommend that you go check out Dan at the Coding Train. There's a link in the description where he has tutorials for processing and P5JS, the JavaScript equivalent, where he does challenges, and he just has these weird and wonderful programming projects that you should really check out. So first of all, what exactly are we making today? The dragon curve is a self-similar fractal curve that's what you get when you fold a piece of paper in half over and over and then you unroll it into right angles. Now Numberphile has a brilliant video on this, so if you'd rather watch their explanation of it, I've linked to it in the description. And if you already know all of this and you just want to get to the programming, there's a time code on screen right now and in the description for you to get right into it. So here we have an animation of each iteration of the dragon curve. So what we're going to be doing today is making it so that every time we click, we advance to the next iteration. So what happens at each iteration is each one of these line segments is cut in half and sort of extruded one way or another such that it forms a new right angle. Now, as you trace along the curve, you'll notice that the direction that you extrude in alternates every time. So in this, red is a anti-clockwise rotation of a segment, and a green is a clockwise rotation of a segment. And as you trace along, you alternate red, green, clockwise, anti-clockwise, and that forms this curve. Now, there are other ways of forming the curve. So for this example, what happens is the curve clones itself and rotates 90 degrees. And over each iteration, that forms a larger and larger dragon curve. Now, this isn't the algorithm we're going to be doing today, but that would be a good extension in future if you so wish. But today, we're just going to be doing the extrusion method, because I think this lends itself a little bit more to object-oriented programming, where each line is responsible for segmenting itself and drawing itself. And that means you actually just need very little code in order to be able to do this, as we'll see. So first of all, I've gone ahead and set up this project, and I've filled out these two methods, well, filled out one of the methods. So for every processing project, there are these reserved methods. There are more, but we only need these two right now. Setup, which runs once at the start of your program, and draw, that runs on every new frame of your project. So right now what I've done is set up a window which is at 720p. I've reset the coordinates so that the center of the window is 0, 0, and I've set the background color to a sort of dark gray. So if we run that, there we go. So before we jump in and start making the 11th iteration of the dragon curve, what might be best to do is just to get a line on the screen. So as I said, we're going to be doing this object-orientedly. So first of all, let's make a line class. So thinking ahead a little bit on what we're actually going to need for these lines, well, we're going to need to know the start and end points of each line, where A is the start point and B is the end point. We want to know what angle is this line at. We will use this to derive the end point. So we will only provide the start point, and then with an angle and a length, we will calculate the end point. So here is what we need to construct a line. We give it the start point, the angle, and the length. We initialize those values and use them to calculate the position of B. I won't go into the trigonometry, but this will displace from A by that angle and length to find B. So now that we can construct a line, we want to be able to show that line. So like I said, a line is going to know how to show itself. So thankfully, processing already has these methods for us to build a line. And in order for it to be a little bit more obvious when we start segmenting, what I'm going to do is place an ellipse at the start point with some radius and an ellipse at the end point. This way, when we start segmenting but we don't change the angles, we can see that we are actually subdividing each segment. So now back in our main file, we're going to declare a line and we are going to initialize it with a start position of the middle of the screen minus half of the length of the line. So we're going to move the start point halfway to the left so that it sits nicely in the middle and give it a length. And then on draw, we want to show it. See if this works. Hey, that's actually quite small, so we can probably get away with making it quite a bit longer. Because the way we're going to do this is these start and end points are never going to move. So this is actually going to be the bounds of our final dragon curve. Actually, what I'm going to do is I'm going to set the background to just a blank white background so that it's easier to see the black line for the time being. At the end, we're going to experiment with coloring this curve, but for now, this will do. So now for the fun stuff. What we're going to do is we're going to write a method in the line class, which is responsible for splitting it into two lines and return them as a new list. So for the time being, we're just going to split the line in half without worrying about any kind of angle. So this is how we do it. So we construct two new lines, line 1 and line 2, where line 1 starts at A, has an angle of 0 and half the length of the current line. Line 2 begins at the end point of our last line and again has no angle and half the length. So if we just add these to our list, and then return them, well, now we have a bit of a problem because in our dragon curve file, we're dealing with just a single line and showing that one line. So what we instead need to do is have a whole array list of lines, which is our entire curve. And let's initialize it here so that we don't get any null pointer exceptions. And we still want to initialize our first line, and then we want to add it into our curve. And then instead of just drawing one line, we instead want to iterate through every single line in our curve and show it. So if we run that, we still have a line. This is where our third inbuilt method of processing comes in. So as you might expect, mouse clicked is run every time we click the mouse. So what we want to do when we click the mouse is split every line that is currently on the screen. So for every line in our curve, split, and then it should continue to draw because the draw method is run every single frame. So let's run that and see. We have one line, we click. Actually, there's that's not the case because we're splitting, but we're still only ever drawing that one line. So actually what we need to do is we need to save up the children from each splitting, add them to the next iteration because we don't want to operate on the same collection that we are iterating through. and then set the curve to be this next iteration. So now if we run it and we click, hey, we have segmented this line into half. So if we click again, quarters, eighths, 16ths, 32s, etc. So now what we need to do is to start messing with this angle. So if I naively rotate the first segment by 45 degrees and the second segment by negative 45 degrees, this will add up to a right angle. And let's see what happens. So you see how the endpoint here moved in. What we need to do is rescale these lines by a different number. So currently we are halving, but what we need to do is scale it by 1 over the square root of 2. Simple Pythagoras. Exercise for the reader. So now if we run that again, these endpoints stay exactly where they are, and we get the first iteration of the curve, I believe. If we look here, there is, I don't know if this is the first or the second iteration, but it's going well. So what happens if we click again? Oh dear. So first of all, something that we have to do is, well, first of all, we don't consider our current angle when we set the angle of the next line, because this is an absolute angle where I'm assuming 0 is up and I guess 2 pi all the way around is up again. So what we want to do is add our current angle to our rotation. So this should at least reattach our curve, and indeed it does. And I mean, this already looks cool. Let me move this up the screen a little bit. Why didn't that move up? Oh, because the top of the screen is actually 0 and the bottom is height. So if we go through that again, we end up with this curve. And this is sort of a sibling curve to the dragon curve. I can't quite remember its name, but it's in the Wikipedia page. Here it is, the Lévy Dragon, or the Lévy C curve. I guess mine's on its side. Here you go. So this is a very similar curve, but what's not happening here is you can see you aren't forming a right angle at every new segment. So as we iterate, what we're going to do is we're going to cut this segment in half and extrude it out this way, and this one this way. And what that's going to do is create this 180 degree angle here, where instead this one should be going in the other direction and forming continuous 90 degree angles along the entire curve. But this is a sign that we're getting pretty close. So if we go back to our initial animation of the curve being extruded from each segment, you can see what's happening is we alternate red, green, red, green, red, green throughout the entire curve. So what we need to do is alternate the direction in which we are extruding each time we split. So currently, the line is responsible for deciding which way it splits, but the line doesn't know about other lines. The line doesn't know which way its neighbor is going to extrude. So what we need to do is add a new parameter to our split method, which tells the line which direction it should extrude. So we'll call that the orientation. So all we need to do is for the positive extrusion, actually for both extrusions, multiply by this orientation. So what that means is the first segment will extrude one way, and then in the Dragon curve file, we will alternate it for the next one, and it will extrude in the other direction. So if we go back here, and let's set a global variable, and we'll set it to 1. So first of all, let's make sure that nothing has changed. Cool. Because we're always multiplying by 1, so effectively it is the same. However, if after every split we invert the orientation, there we go. So now we have what looks like the third, oh no, I've closed it now. The third iteration of the Dragon curve. Well, I guess the second. So if we click again, what we should see is this sort of W with sort of a swan's head looking one. So if we click again, there it is. Mine's backwards, I guess, because of pixel space being 0 here and width over here. But as we keep clicking, the shape of the Dragon curve should appear. So now that we have a functioning Dragon curve, we can start to have some fun with it. So if we set our background back to that sort of dark gray, what we can do is, as we iterate through the curve, we can go through the color wheel and say start at red and end at blue. So there's a way you can do this in processing that's super simple. So if you come into the draw method, we set the color mode to HSB, hue, saturation, brightness. We want to go 360 hue, 255 saturation, 255 brightness. So instead of RGB mode, where we set the red, the green, and the blue values of every pixel, we're going to set the hue with a single number. So we need that number. So we need a hue value, call it H, and we map this I from, which goes from 0 to the size of the curve, and that goes from 0 to 360. And we then want to set the color to that hue with a brightness of 255 and a saturation of 255. So if we run it, we have a red line. Click again, red, blue, red, green, blue, violet, and if we keep going, we get, and you can see the direction of the curve as the color changes from one to another. Sorry, small mistake I just noticed. I was setting the background back to 255 every frame. So now, if I get rid of this, if we set it to 0, it should be a black background, which I actually think looks a bit nicer. Ooh, we were actually setting it every frame in the draw for a good reason. I'll leave this in because this is a good lesson. If we don't set the background every frame, we persist what was drawn on the last frame. So if we reset it every time we draw, there we go. And we get our wonderful rainbow dragon curve. Also, just for the sake of completeness, if we do not flip the orientation every time, and if we just move this back up, here is what the C curve looks like as we do this. I actually really like this visualization because you can see how it kind of loops around itself. So you can see it kind of comes around here, goes behind, comes back round over and over again And it's a fractal, so like if you zoomed in with infinite precision onto, say, this section here, it's self-similar, which means that this is exactly the same as the full curve, and then this part here is exactly the same as the next curve up and the next one up, etc., etc. And in fact, every time we do the iteration, we just fill in another level of detail, but I think we've exceeded the resolution of my monitor at the moment, so any more clicks is just gonna, all it's gonna do is heat up my CPU really. And there you have it. With relatively few lines of code, we have generated this incredibly complex looking shape. And this is actually one of my favorite things to do with software like this, is to make fractals, because there's a certain degree of recursion with them, you don't actually need a huge amount of code in order to produce something like this. And you can just tweak different parameters, like with the whole not alternating your orientation, yielding you this entirely different but equally astounding curve. I would love to see like what people do with this code, and just let me know if there's anything that you would like to see me tweak with this, or to do in maybe another video, because I actually really enjoyed doing this, and I really enjoyed the challenge of having to come up with how to do this myself, seeing as Dan hadn't actually done this yet. So yeah, thank you for watching, and hopefully I'll see you next time.